Folks, we are moving quickly through this particular unit, Unit 7. We're going to do some of the introductory calculations for chemistry. The first one we learned was using the molar mass. If you know the molar mass, what can you always convert it to? If you know mass and you have a periodic table, you can always convert it to what? You can always convert it to moles. Right here in 7-10 class notes, I've put on a table a summary of the types of calculations that we have now learned to do. As we mentioned, if you know the mass that you have, you can convert it to moles. If you know mass, you can convert it to moles. If you know moles, you can convert it to mass, provided that you have a periodic table of elements. All you do is add up the molar mass using the periodic table of elements, using the formula. The molar mass is the mass of 1 mole. That is an equality. The equality we can establish. What is the mass of 1 mole from the periodic table? The equality is written right here between these two arrows. In the calculations, I hope you've made some observations just from doing these. If you have the mass and you want to know the moles, all you had to do is divide by the molar mass. You divide by the mass. 1 mole over the mass. Yes? For instance, water has let's just round it to 18.02. The mass of 1 mole of water. The mass of 1 mole of water is 18.02. If you have 36.04 grams of water, how many moles do you have? 1 mole's 18.02. If we have 36.04, you would have 2. You divided by the mass. When we go from mass to moles, we're going to moles. The mole will be on top. The mass will be on the bottom. Wherever you're heading to, whatever you're converting to, in your conversion factor, whatever you're converting to is on top. So if we're going to moles, it's on top. If we're coming from mass, it's on the bottom, so that mass can cancel out. If we know the number of moles we have and we want to find the mass, we're going to mass. The mass would be on top. We said water had a mass of what? 1 mole of water is around 18.02 grams. Our equality, 1 mole of H2O is 18.02 grams of H2O. Let's say we have 10 moles of water. What would the mass be? So you took what? 10 times the mass, yes? It tells us to do it right there. The mass went on top, 1802. The moles are on the bottom. When we're leaving from moles or when we're going to moles, there's always a 1 next to it. Our conversion, you're like, well, we have 10 moles. We have 10 moles. Question mark. How many grams of water do we have if we have 10 moles of water? How many grams of water do we have if we have 10 moles of water? Here's our conversion factor. The 1802 went on top. 1 mole went on the bottom. 10 times 1802, it was 180. You see how that's working? This table just gives us a summary. What does the expression look like? What does your conversion factor? Here's our equality. We have an equality, that is between the arrows. If we divide both sides of this equality by the mass, grams, the mass in grams. If we divide both sides by the grams in mass, the mass cancels out 1 mole over the grams. That's this conversion. When you have an equality, remember what you do to one side, you can do to both sides. Likewise, here's my equality. If I have 1 mole, I can divide both sides by 1 mole. 1 mole over 1 mole is 1. There's my second conversion factor. Do you remember doing this? This table just kind of summarizes how to do this. The other day, I believe it was Tuesday. On Tuesday, we learned to do this conversion. We learned that you could go from moles to quantity count. That is a number. And we learned that you could go from quantity count to moles. Quantity count is just what quantity of something do you have. In chemistry, we might be talking about formula units. Formula units would be how many would pertain to salts. Because remember, the repeating pattern of a salt is a formula unit. If we're talking about specific ions, we could ask that. In other words, how many sodium ions or chloride ions do we have in table salt? If it's a covalent substance, we could say, how many molecules do you have? If it's an atom, you could ask how many atoms it has. These are the units that go with quantity count. What number is moles related to that enables us to convert back and forth to a quantity count? The answer is Avogadro's number. 1 mole is defined to be the number of atoms that would be present if you have 12 grams of carbon-12. Turns out it's 6.022 times 10 to the 23rd atoms. 1 mole is 6.022 times 10 to the 23rd. Of what? Of anything. Of anything. Once again, we notice that if you go from moles to mass, the moles on the bottom, mass would be on top. If we go from mass to moles, whatever you're going to is on the top. Moles would be on top. Mass is on the bottom. Same thing here. If we're leaving moles and going down to quantity count, what we're going to is on top. Avogadro's number would be on top. What we're leaving, moles, is on the bottom so that it cancels. If we're starting with the quantity count and we're going up to moles, we're going to moles. It needs to be on the top of the expression so the unit does not cancel out. If we're leaving quantity count, Avogadro's number will be on the bottom. What unit goes with Avogadro's number? Formula unit, molecules, atoms, ions, whatever it is you have is the unit. Anytime we're dividing by Avogadro's number in the expression, it's smart to put it in parentheses so that your calculator, are you listening? You want to put it in parentheses so that your calculator does not get confused on orders of operation errors. So if I have a calculator, let's say I am asked a question something like this. How many moles of carbon dioxide would I have if I have 1.204 times 10 to the 23rd molecules of carbon dioxide? How many moles of carbon dioxide do I have if I have 1.204 times 10 to the, make that 24th? Did I say 24th or 23rd? If I have 10 to the 24th molecules of CO2, how would we do that? We're given a quantity count, molecules. There's the unit down there. And we're asked for moles. We're going to there. So I'm going from quantity count up to moles. There's my arrow. Do you see that? I'm going up. Here's the conversion factor that I would use right next to the arrow. All you have to do, you're allowed to use this chart on your homework. All you have to do is read, what is the question? How many moles? So I'm going here. How many moles do you have if you have 1.204 times 10 to the 24th molecules? I am down here. Molecules unit is there. I am given a quantity of something. There's the arrow I'm going up. Here's the equality I need. 1 mole is 602 times 10 to the 23rd. I'm going to moles, so I need that on the top. I'm leaving quantity count, so I need Avogadros on the bottom. Now, here's where we have to be careful on our calculator. Here's a little line right here. How would I enter this on my calculator? 1.204 times 10 to the 24th times this expression. How would we enter that on our calculator? How do we enter our calculator so that we can put things in scientific notation? How did you do it on your calculators? We've done these kind of problems. Does anybody tell me how to input this? Yes.
1.204 times e to the 24.
All right. Or you can use the caret. Some of your calculators have a caret. You can say 1.204 times 10 caret 24, the little thing. Yes? Or you can use E. Now, here's what you have to be careful of. You would take 1.204 times 10 caret 24. Now we have this on the bottom. We have this on the bottom. How would I enter that? Yes.
You could enter it as a fraction, or you could divide by it.
You could just divide by it because 1 is on the top. You could just divide by it. So really, this is 1.204 times 10 caret 24. You can use the E divided by, and we're dividing by it. Put the parentheses in it on your calculator. Try this on your calculator right now to see if you get the correct question, to make sure you know how to enter this. If you don't use parentheses, if anytime you do a problem like this and you get 10 to the 40 something, like 10 to the 47th, 10 to the 46th, 10 to the 48th, you have an order of operations error. It's thinking you're multiplying by 10 to the 23rd instead of dividing by it. What do we get when we do this? Can you see the problem okay? 1.204 times 10 to the 24th is on top. Avogadro's number, 6022 times 10 to the 23rd is on the bottom. Those of you that have calculators where you can store numbers as constants, a lot of students will put in Avogadro's number. What did we get for this answer? If you got 10 to the 40 something, you are multiplying by the 23rd. You didn't use parentheses. 10 to the 23rd. What did you get?
1.999.
You got 1.999.
1.9993357.
Okay. Maybe we should make this 1.2. You got, what did you say it again?
It was like
1.99. Almost 2. Yes? 1.99 what? 999. So that we're only allowed to keep 4 numbers in our answer. So we would round that to what? 2. What did you type? Did you type 1.204? Oh, that looked like a 6 to you. Yeah, that would make sense. If you got 10 to the 40 something, you didn't use parentheses. Did any of you guys use the parentheses for the number on the bottom? Now, how did you enter on your calculator something into scientific notation? Did you use the caret? Okay, the caret button's pretty easy. The caret button makes it pretty easy. All right. If we're going from moles down to quantity count, Avogadro's number's on the top. There, you don't have to worry so much about it. You can kind of type it in straight across without worrying about the parentheses. Yesterday, Wednesday, we learned to go another direction. We learned to go from moles up to volume, or from volume to moles for substances that are in what state of matter? This is for gases only. This is for gases only. We learned to go from moles to volume or from volume to moles. We would use the fact that 1 mole of any gas takes up 22.4 liters of space at STP. At STP. STP stands for standard temperature and pressure. What is the pressure at STP? What is the selected pressure for STP? 1 atmosphere. What's the selected temperature? 0 Celsius. 0 Celsius. If the gas is at a different pressure or at a different temperature, you can't use this conversion. You can't use this equality. Because as the pressure goes up above 1 atmosphere, what's going to happen to the volume? As pressure goes up, what happens to the volume? The volume of the gas goes down. As temperature goes up, what happens to the volume of the gas? It goes up. The volume will increase. Yes, these are some gas laws. These are some gas laws. If you take a look at your notes here on this particular section, let's take a look real fast just to show you why this whole molar volume thing works. If you have a gas particularly at STP, 1 mole of gas will always be 22.4 liters. This is the note 7-9 that tells you that how much space a gas takes up depends on pressure. It was Boyle's law that says that if you increase the pressure on the gas, the volume goes down, assuming the temperature, the amount of gas are held constant. We just mentioned that as the temperature increases, so does the volume. That's called Charles's law. Avogadro's law said that if you increase the amount of gas in moles, the volume goes up. In other words, if you keep blowing more and more gas into a balloon, the balloon's going to take up more space. Now, obviously, the pressure will eventually start changing as well. But if you hold pressure and temperature constant, the more gas you have, the more space it takes up. And the Gay-Lussac law, increasing the temperature on a gas in a confined space will increase the pressure, like a pressure cooker. You increase the temperature, the pressure goes up. On a stove, if you have water and you put a lid on the pan and you turn the temperature up, that water will start boiling. It will go to a gas. If you keep the temperature up, the pressure of that gas is going to continue to go so much that eventually it can blow the top off the lid. That's how pressure cookers kind of work. But back to what we were looking at here. If you happen to have a gas, if you happen to have 1 mole of gas. Oh, here's something to note. See how we have 7-11 right there? That's tonight's homework. You may see when you click on this week that you won't see 7-11 right in front of you. Because if we get a certain number of assignments, it starts hiding them. Are you listening? And you'll have to click on down here somewhere. It'll say view more. You may not see 7-11. You might have to click on view more and then it'll pop up because it has to start hiding them. When we are going, again, this chart is a great chart to use to make sure you have the problem set up correctly. If we're going from moles to volume, we're going to volume. From moles to volume, we're on this arrow right here. The volume's on the top. We're leaving moles. It's on the bottom. If we're going from volume back to moles, whatever we're going to is on top. 1 mole will be on top. The molar volume, 22.4, will be on the bottom. That's how this chart can be very, very helpful to make sure you have problems set up correctly. Let me give an example problem for you to look at. Folks, here's why we have this chart. Moles will not be a part of every single problem that we do. With this chart, I want you to take a look at something. With this chart, we have opened up a whole bunch of different problems. For instance, I could give you a volume of a gas and tell you it's at STP. Could you tell how many moles it was? Absolutely. If I give you a volume, you could tell me how many moles it was by dividing by 22.4. But could I not ask you what quantity of molecules are in the gas? Let me show you what I'm talking about. This is going to be absolutely spectacular. If I give you a volume, I could now ask you for a quantity count. I could ask you how many molecules are in the gas. I would not ask you how many formula units are in the gas. Why not? I wouldn't be able to ask you for how many formula units. Yes.
But it's not a salt. It's
Yeah, formula units pertain to salt. At 0 degrees Celsius, salts are solid. You can't convert that using the molar volume. It would be a solid. It has to be something that's a gas. So how would we set a problem up? If I asked you for a quantity count, this would get it from here to here, yes? Then my next expression, I would now be going down this arrow to quantity count. This would get us the rest of the way. So this would be our first conversion. This would be our second conversion. You see how this chart works? With this chart, you'll set up every problem very well. Could I give you a mass and ask you for how many atoms are in it? I could be like, you've got a copper pipe. It's pure copper. The mass of the copper pipe is whatever, 36 grams or something like that. I could ask you how many atoms are in that copper pipe now. Could I ask you the volume of the copper pipe?
no.
Well, I could, but I would have to give you the density of copper. We couldn't use molar volume because it is not a what? Copper's not a what? It's not a gas. We couldn't use this conversion. All right, let's hopefully look at how to set up one of these problems using this chart. These are called two-step problems. Two-step problems. The problems we're doing tonight, you're going to use the types of problems that we have done Monday, Tuesday, and Wednesday of this week, except it's going to involve two conversions. On tonight's homework, when you open it, since we're using two conversions, it will be what? It will be sideways. How will you get that? Because we got to have it landscape so that you can set the problem up. One conversion can be portrait, right? But we had to flip it and make it landscape. How do you get it using Cami? How do you go from something that's sideways to get it so that you can see it without turning your Chromebook sideways? Open it in Cami, click on the three lines. Click on the three lines in the upper right-hand corner, and you'll have the option to rotate it. You see the option to rotate it? The option to rotate it, I think you got to go counterclockwise to get it so that it'll rotate it so that you can actually do the work. Are you following me? Did anybody try that yet?
Yeah, it works.
It worked. There's three lines in the upper right-hand corner. It will give you that option. Let's show you how one of these problems work. You would like to do that, wouldn't you? Or do you guys not want to do this? Here's an example problem in our 7-10 notes. How many water molecules are in 500 milliliter water bottle? Many of the water bottles that you bring to drink at school during the day are about 500 milliliters. How many molecules are in there? How many water molecules are you drinking if you drink your standard 500 milliliter water bottle? Assuming the density of water is very close to 1, and it is, that would mean you had how many grams? If the density of water is right around 1 gram for every milliliter, if it's 500 milliliters, how many grams of water would you have? 500. So really, we have 500 grams. So in this problem, they've given us a what? In this problem, they've given you a mass, yes? And what are they asking for? They've given you a mass. It's 500. What have they asked you for? What are we trying to solve for, folks? Come on. I should not delay here. How many what? Do you see the question there? How many molecules? That is a what? Is that a volume? It's not a volume. Volume would be in liters. They didn't say what's the volume in liters. It is a, thank you for answering, it is a quantity count. You're like, how do I know that they've given us a mass? Because they gave you a mass. How many molecules? If we look at our chart, here's the unit molecules. It's right there. They've asked for a quantity count. If you see liters, it's a volume. If you see moles, it's a mole. If you see formula units, ions, molecules, or atoms, it's a quantity count. If you see grams in there, it's a mass. They gave us a mass, yes? They gave us a mass in this problem, 500 grams. And they're asking for a quantity count. How do I get there? I follow this arrow right there. My first setup, I would need 1 mole over what? I would need 1 mole. My first conversion factor, I'm going to need 1 mole over the molar mass from the periodic table of elements. That would be my first conversion. So when we look at this problem, I'm given 500 grams. That goes right there. My first conversion had mole over grams, yes? My first conversion has mole over grams. Here it is. I'm right here. I'm going there. Do you see the mole over grams? Where do I get the grams from? It comes from the what? It tells you right here. From the periodic table. So I have to add up the molar mass of water. So to do this problem, I have to add up the molar mass of water. They've added up the molar mass of water right over here. It's 18.02 grams. Here it's written as 18.016. It's 18.02 grams. So I'm going to put 1 mole over 18.02 grams. That's my first conversion. Now I'm at moles. Where do I have to go? I am now at moles, and I have to go to a quantity count. There's my conversion. Avogadro's number over 1 moles. I just follow the arrow. Bam, bam. There's my second setup. 6022 times 10 to the 23rd over 1 mole. That should be the second thing in the problem. There it is. 6.022 times 10 to the 23rd. How do I know I have this set up correctly? I pulled the conversions right off the chart. How do I know I have it set up correctly? Watch this. What unit am I giving? Grams. Does grams cancel out or factor out? There's grams. This unit cancels. I am now at moles. On the chart, I went from mass to moles, but I have to factor out moles. Do I have a factor? Do I have a way to cancel it? Right there. What unit am I left with? I'm left with molecules. That's what I'm trying to find. How many molecules? So this cancels, this cancels. There's the unit I'm left with. How would I punch this in my calculator? Could I take 500 divided by 18.02 and hit equals? Then I can take it times 6022 times 10 caret 23. I should get the answer. See if you get the same answer I got on your calculator. This is how we use this chart. By the way, use the chart. Use that chart when you do the problems. Tonight we have 7-11. You want all your units in the problems when you do those? You want the units in the problems. You want the formulas in the problems. Take the time to do this stuff. Did you try it on your calculators? If you don't have a calculator, we are using them this entire 9 weeks, all day, every day. Your calculator is going to feel right now as though it is attached to your body. You should wake up with your calculator underneath your pillow. Put your calculator in a zip box if you take a bath. That calculator needs to be with you everywhere. You go to eat, calculator's there. Keep it protected. Don't spill something on it as you're eating. When you go to the bathroom, Ziploc bag, your calculator should be a part of you. You don't want to accidentally drop it in the toilet. But wherever you go, the calculator should be nearby as though it is a body part. Did you guys get 1.67 times 10 to the 25th? Did anybody have trouble with that? If you're having trouble with it, let's talk about it so that we can make sure you know how to enter things into scientific notation. We have 7-11 for homework. Do you want to see another example problem, or are you confident you can use the chart? Anyone? No thoughts, no feelings? Well, there are other example problems on there if you want to look at those. If you're ready to roll on the homework, let's do it. Oh, did you get problem 4 and 5 questions yesterday? What was wrong with those problems? Number 4, it gave you a problem and I said, what is wrong with it? What was wrong with number 4? Does anybody remember on last night's assignment? It wasn't a what? It wasn't a gas. It was a liquid. Yes? You can't use the molar volume if it was a liquid. What was wrong with the second problem? It wasn't at STP. The nitrogen being put in the tire was not at STP. A tire pressure is way above STP. Good job on those if that's what you got on number 4 and 5. Good luck with your homework. Is there an answer key that you can compare your work to? Use the answer key to check. Don't do it like check it after every problem. Compare it, check it. Good luck.